Hello and welcome. So in this video, we're going to be solving June 2015, and the first question which we have in 2015 is a very similar question. So this video is going to be just one part. This first question, which is on partial fraction, demanding you to express a partial fraction, you will have to solve it as a homework because we have already covered similar problems in the previous videos. And if you're new, you haven't watching our previous videos and you don't know what's going on, we're presented in the series, so you can check out other videos and try and get yourself familiar with it, or you can check out a playlist on partial fractions. So we head straight into the second question of the year 2015, and the question is actually an inequality question, and this is the type of question which we have not yet seen. So I would like to solve this. The question reads: find the set of real values of x for which the absolute value of 3x plus 4 divided by 2x minus 3 is less than 1. So what do you do here? But absolute value of negative 2, well, it's 2, right? Okay, now in terms of absolute value here, due to represent some absolute value, what we're going to do here is to square both sides of this problem. Okay, so this just tell this value here can either be positive or negative. So squaring both sides just tell if you take a square root, you can either have a positive or negative value. And now in terms of absolute, we'll get just the positive value. So approaching this problem, squaring both sides to get rid of the absolute sign, we're going to have 3x plus 4 divided by 2x minus 3, or that squared is less than 1 squared. Okay, is less than 1 squared. Now moving to the next step, when you take a square, so we're going to have 3x plus 4 less than, you're going to have to do a cross multiplication operation here. So we're going to have 2x minus 3 into 2x minus 3. This will imply that we're going to have 9x squared plus 24x plus 16 is actually less than 4x squared minus 12x plus 9. Now bringing the like terms together, or taking the values on the left hand side to the right hand side, or the values on the right hand side to the left hand side, we're going to have something like this. So here we're going to have 5x squared plus 36x plus 7 equal to 0. Now solving it by either method of solving quadratic equations, we're going to have 5x squared plus x plus 35x plus 7, less than 0. Let's see, I have a less than 0 here. Continue proceeding with the factorization, we get x into 5x plus 1 plus 7 into 5x plus 1 less than 0. Now we need to get the boundary values or the critical values, and here from here it implies that our critical values are going to be, well, actually have to equate them. We're not going to simply have a less than or greater than. So here x equal to negative 7, or x equal to negative 1 on 5. Now I have to show you something again. In the previous video I explained this particular concept of how you can easily get the limits. Okay, now for the smaller value, first of all, take before that smaller value, I guess I will have to show you the image again. Okay, so this is something similar from the previous video. What I actually did was that I had two values. I had 2 and 4. Now, it depends on the number of values I have. If you follow the same procedure, okay, if you follow the same procedure, I'm pretty sure in the next video we're going to have a situation where we're going to have 3 situations like this. But before we reach that particular situation, if you could please post any attempt of yours in the comment section so that we can all see how it looks like. So what you do is that you have your two values. In this case here, we're going to have our negative 107 and negative 5. So our negative 7 is going to be here, and negative 105 is going to be here. Okay, so now the range, we need to get a range, certain range of values, certain region, certain area. Now we can start either before we reach these values. They can either be, since they are not equal, actually equal to, so they can be in this range before reaching, in this case we're going to be negative 7. Let me just have it here. So before reaching negative 7, or again another space, we have negative 7 to this other number, because so we have to negative 7 to this negative 1 and 5, or we can see check after negative 1 over 5. So that's the main idea you need to get here for it easy to understand how you can derive it. Don't just try and cram it, please. So here we're gonna have x less than negative 7, negative 7 less than x less than negative 1 on 5, and x greater than negative 1 on 5. Now, what factors do we have here? We have the following factors: x plus 7, 5x plus 1. But we're not actually going to substitute them into these values. We're instead going to substitute them into these values here. Okay, now when x is less than negative 7, we can have value like negative 8 and negative 9. Okay, now forget about this square. Actually, the square was not originally, but again, you can still substitute it here. You see, have the same result. So substitute negative 7 here, we're gonna get a negative value, and again, the same goes for this other side here. Let me try and draw a perfect line. And now when you multiply the two, you get a positive. Now between negative 7 and negative 1 on 5, we can have a value like a negative 3. So to negative 3 here, we get a positive value. Here we get negative, negative, a value of greater than negative 1 on 5. Let's work with positive value. We can have a value like 2. Positive, positive, positive. If you have noticed, we always get a positive, positive, positive on the last one, and we always get an interchange here and here. We get negative, negative, positive. But I doubt this is really the case. Now let's get back to the question. The original question was actually less than 1, so we're going to check the negative value, and this is going to be our answer. So we're going to have this as a set of values: x for negative 7 less than x less than negative 1 and 5. Okay, so that's all for this problem. See you in the next video, and please don't forget to check out the other playlist and enjoy yourself while solving.